For section 3.3, we're going to be looking at your point-slope formula. Your essential question for today is how can you use the point-slope formula to write the equation of a line? Now the point-slope formula looks like this, and you've seen it before. This should be a review. It's y minus y1 equals m times x minus x1. Now this equation has one purpose and one purpose only. This is used to help write the equation of lines. That is its sole purpose. We use it to help us write equations of lines. Now what you're going to do is you're going to need a point and a slope to use the point-slope formula. So I want you to do some word association. You're going to need a point and a slope for the point-slope formula. You're going to plug a number in for x1, you're going to plug a number in for y1, and you're going to plug a number in for m, or slope. So there's your point and there's your slope. Once you plug those in, I'm going to show you how to manipulate this equation and get it into either standard form or slope-intercept form. Let's go ahead and start with our first example. Our first example is if I give you a slope and a point and hand it all to you. Let's say all you know about this line is that its slope is a positive 1/3 and it happens to go through the point negative 2, 5. What you're going to do is the minute I say write the equation of the line, you're going to say, oh, I need to get out my point-slope formula. That's how we write the equation of the line. And remember, we need a point, an x and a y, and we need an m or a slope. So once I plug this information in, instead of y minus y, the y that I'm given happens to be a 5 up from up here. So instead of y minus y, it's y minus 5. Equals, instead of m, I'm going to put in my 1/3, that's my slope. And instead of x minus x, I'm going to put in an x minus a negative 2, because my x is a negative 2. Now minus a negative 2 becomes a plus 2. Now this is all fine and dandy, but what you're going to be tested on is getting this equation into slope-intercept form, and you're going to be tested on getting it into standard form. So you're going to need to be able to do this in slope-intercept form, and you're going to have to be able to write this in standard form. So let me show you how to manipulate this so you can get it written in these forms. You always want to start with slope-intercept first. To get slope-intercept form, what you do is you need to get the y by itself. So the first thing I'm going to do is distribute my 1/3 in. And last but not least, I'm going to add my 5 over. Now I'm going to come over here in the corner in red. 2/3 plus 5 over 1. I need to get a common denominator of 3. 2/3 plus 5 over 1 is 17/3. Now this is slope-intercept form. So you just wrote this equation of the line in slope-intercept form. Now I also need to write it in standard. To write it in standard, what we need to do is take this x and move it over with the y. So take this entire x and move it over with the y. Well, that happens to be a positive 1/3 x, and to move it, I'm going to subtract a 1/3 x. So to write this in standard form, we want to write the x first, so I've got a negative 1/3 x. I've got a positive y, and it equals 17/3. So that's my standard form. Here's my slope-intercept form. Here's my standard form. All right, for our second problem, I've got the point negative 2, 6 and the point 1, 4. Now if you remember way at that very first screen, when I say write the equation of the line, you automatically pull the point-slope formula out of your bag of tricks, if you will. You know you need a point and a slope. The problem is I don't have a slope here. I've actually got 2 points and I don't have a slope. Well, do you guys remember how to find slope between 2 points? Sure you do. You subtract the y's on top, so in this case 4 minus 6. You subtract the x's on bottom, in this case 1 minus a negative 2. So I subtracted 4 minus 6 y's, 1 minus a negative 2 x's. And what you end up getting is negative 2/3. My slope in this case is going to be negative 2/3, and that's the m I'm going to need to use. Now which point do I use? Actually, it doesn't matter. You get the same answer either way. I'm going to go ahead and use the first point, but you could use the second one. You'd get the same answer. So let's go ahead and plug this in. Instead of y minus y, I'm going to have y minus 6. Instead of m, I'm going to have negative 2/3. And instead of an x, I'm going to have a negative 2. So x minus a negative 2, which of course becomes a plus 2. Now, just like we said before, you're going to need to be able to write this two ways. You're going to have to be able to write it in slope-intercept form. You're also going to be asked, to write it in standard form. The first thing we do, if you remember from the last problem, is we get the y by itself and write it in slope-intercept form. The way we start that is by distributing that slope in. And what that becomes is negative 2/3 x minus a 4/3. Then we add our 6 over, add our 6 over. I'm going to go over here to the side, just like I did on the last problem. We have a negative 4/3 plus a 6 over 1. Got to get a common denominator. The common denominator is going to be 3. And you end up getting 14/3, or a positive 14/3. Now that is slope-intercept form. Once the y is by itself, you're in slope-intercept form. Good thing we reviewed fractions in Chapter 1. Now I need to get it in standard form. And to get it in standard form, if you remember, you need to take this x and move it over with the y. So if I need to move a negative 2/3 x, I'm going to add 2/3 x. Now remember, we want to write the x first for standard form. So the positive 2/3 x is going to pop out to the front, plus y equals 14/3 is going to be your standard form. So what you've done is you've taken these 2 points and you've written the equation of the line both ways. All right, let's look at our third example. Once again, the minute Ms. Chapeau says, write the equation of the line, you guys should say, all right, let's pull out our point-slope formula, meaning I need a point and a slope. Well, I have a point. I've got an x and a y. It's right there. What I don't have is a slope. What I do know is I want it parallel to this line, and if you guys remember, parallel slopes are exactly the same. So if I can find the slope of this line, I can use the exact same slope, and that would be considered a parallel slope. Well, if you remember, to find slope, you got to get the y by itself. So the first thing I do is subtract that 2x over, and then divide by this 3. It looks like the slope of this particular line happens to be a negative 2/3, and since I want my line to be parallel to a negative 2/3, I also want to use a negative 2/3 for my slope. So instead of y minus y1, it's going to be y minus 5. My slope is going to be a negative 2/3. My x is going to be minus a negative 4 or a plus 4. Once again, don't forget we have to be able to write this two ways. We have to be able to write this in slope-intercept form. We also have to be able to write this in standard form. First thing we do is distribute that negative 2/3 in, or that slope in. And then we add our 5 over. Okay, I'm going to come over here to the side again. We have a negative 8/3 plus 5 over 1. Need to get a common denominator. It'll be a 3. That'll be 7/3, positive. So slope-intercept is y equals negative 2/3 x plus a 7/3. If I need to go ahead and get this in standard form, what I'm going to do is I'm going to add that 2/3 over here. So it's going to be positive 2/3 x, positive 2/3 x. Now remember, we want to write our x first. So it's positive 2/3 x. Then we pop that positive y out to the back, equals 7/3. This is your slope-intercept. This is your standard form. Let's look at our last and final problem. So once again, I ask you to write the equation of the line. You know that you need to use this formula. You also know you need a point and a slope. You have your point. It's negative 4, 5. You need your slope. Now the only thing I know about this is I want it to be perpendicular to this equation right here. So if I can find the slope of this equation, I can obviously find the perpendicular slope by doing the negative reciprocal. So remember, to find the slope of the line, you manipulate it and get that y by itself. So the first thing I'm going to do is subtract my 2x over, and then I'm going to divide by 3. The slope of this current line is negative 2/3. The opposite reciprocal of negative 2/3 is positive 3/2. So if I want to use the perpendicular slope, I'm going to use the positive 3/2. Now let's come over here to our equation. Instead of y minus y1, it's y minus 5 Instead of m, it's 3/2. Instead of x, it's x minus a negative 4, and minus a negative becomes a plus 4. Once again, we know that we need to get this into slope-intercept form and into standard form, so I'm going to do that. Distribute my 3/2 in. And oh my gosh, that 12/2 is going to cancel our fraction. And for the first time, you guys, we are not going to have a fraction on this one. Isn't that nice? We're going to add that 5 over. And for slope-intercept form, you're going to have positive 3/2 plus 11. So for slope-intercept form, we're going to have a positive 3/2 x plus 11. Now for standard form, we need to take that positive 3/2 x and subtract it over. We want our x to come first, so it's going to be negative 3/2 x plus y equals 11. So there's your slope-intercept, there's your standard, and those are your two answers.